So here we'll be using simultaneous equation in real life. So I want to look at the application of simultaneous equation in real life. So I want to use both methods in this one example, because as I said, we could use both methods to solve a pair of simultaneous equations. So let's look at a scenario. So it says, at a college bookstore, some purchased a math textbook and a novel that cost a total of $54, not including tax. If the price of the math textbook M for math is $8 more than 3 times the price of the novel N for novel, which system of linear equations could be used to determine the price of each book? Solve the suggested equations to prove your answer. Well, we could use any one of the equations, and I want to use both of the equations to solve the same, solve this problem, and to see if using both equations will actually, do us any justice, or if it makes any sense. So first, we have to come up with, let's say, a pair of equations. Let us try to read this some more and try to get an understanding of what we're supposed to do. So now, if you should look carefully, it says that the math textbook and a novel cost. So let us use M for math plus the novel is equal to $54, and it says let's see, it says that M is equal. So if M is we can use equal for is $8 more than 3 times the price of the novel. So that's an equation that we have. So actually take this real life scenario and we actually formed a system of equation. So we can actually use we could use the elimination method, or we want to use the let's see, elimination or the substitution method. It doesn't matter. So what you can actually do is just to rearrange the equation in such a familiar way that we are used to. So what we could actually do is to rearrange this equation, looking like this, where we have the constant being the subject in the equation. So we could actually rewrite this as let's just say we could say M plus N is equal to 54, and then what we'll actually do is to subtract both sides. We'll subtract this from this equation to actually have 8 by itself, and so we just have the equation being the subject as relates to the constants. So we could subtract both sides by that. So we subtract both sides. So because let me just write this another way. So we could just say, so since that this is the one that we're actually rearranging, so we could subtract both sides by n, 3n. And so if we should rewrite our equations, this is what we will have. We will have M plus N is equal to 54, and down at the bottom here we'll have M minus 3n is equal to 8, and we actually use an equation like this. So this is in terms of M and N, math textbook and the novel. So let us see now. If we use this, let us use the elimination method first. It doesn't matter which one. So elimination method says we use the coefficient of the variable in the equations to multiply the equations. So if I choose to get rid of M first, or it doesn't matter M or N first, to find the value of N or N, and then we plug in the values and so on. It doesn't matter. So if you look at the coefficients of M, the coefficient of M is 1. So if I want to get rid of M first, this is what I have to do. I will take the coefficients, multiply, and if we should do that, they actually have the same thing. And this is the thing. This is the thing. If you multiply 1 by everything, you get the same thing. But we never had to do that. We never, because we always want to have two identical terms in the equation. And that's what elimination does. Having two identical terms in the equation, and then you decide to subtract or add to get rid of them. So what we could do with this equation, we could actually subtract this equation to get rid of this m, these m's. So let's look at it. So we could say, this is equation 1, this is equation 2. So we could subtract equation, let's say we could subtract equation 1 from equation 2. So if that's the case, what we're going to do is to say equation 1. So we're going to say m, which is this m minus this m, plus, well, we're actually rearranging the equation in substitution. So we would say this n plus this n minus that n, that term, minus because this is an original negative, and then what we have equal to 54 minus 8. So we can just group like terms and simplify. So this will give us 0, and now if we look at this becomes a positive. So we have n plus 3, and it gives us 4n equal. So we have what, 46, and if we should divide both sides by 4, we get this. N will be equal to, if we should reduce this in its lowest term, we get 2 into this goes 2 times, and 2 into this goes 23 times. So we have 23 over 2. And so since we find the value of n, we could use any one of the equations to find the value of m. But I choose to use equations. See, we have two equations. We have equation 1 here, and we have equation 2 here. I choose to use equation 1 because it seemed very easier to use. So I'm going to use equation 1. So equation 1 says m plus n is equal to 54. So this is how you say that a textbook plus and now is equal to $54. So let's look at it now. If n is, if substitute n for 23 over 2 is equal to 54. So we could make m the subject. So since this is a positive 23 over 2, we could subtract both sides by this fraction. That cancels that, leaving us with m is equal to 54 minus 23 over 2. And we can create a fraction by this, and we can actually use the LCM method, or we could actually solve this in such a way that both fractions share same denominator. So we could actually multiply this denominator by 2. Well, this fraction, the entire fraction, by 2. So we will have m is equal to 108 divided by 2 minus 23 divided by 2. And so since we have both denominators, we could just say m is equal to, let's say, is what, 85 over 2. So this can be simplified any further. So the value of m is what, 8. Right, that's the value of m. So what we could actually do is to prove if these are actually correct. We could actually, since there it is talking about money, we could actually work out these fractions. So we could say so seeing, let us convert these to actually, let's say, dollars and cents. So this is actually equal to, let's see, 42.5, and I believe the value of n was 23 over 2, which would be 11.5. So we could actually use these values to plug them into the equation and see if it actually works. Because so we could say, then we're saying then the price, well, this would be the answer, but we could actually evaluate to see if this is actually true. So the value of one of the textbook, that one of the textbook is $42.50, while the price of one of the novels is $11.50. But we could actually prove this is true. Let us use any one of the equations to prove it. I want to use, let's say, we could actually use this equation. We could use equation 1 to see if when we add them, if they will give us 54. So let's go. So m plus n is equal to 54. Let's see if the value of the n and the m is actually 64. So we say the value of m is what? 42.5 plus n is 11.5. If you add this, we get 54. You can check it for yourself. So it is indeed correct. So let's look at the substitution method in using this to see if it actually works with the substitution method. What we had m plus n is equal to 54, and we had what was it again? It was at m minus 3n is equal to 8. So which one of these equations seem to be easier to rewrite or to make the subject? To me, you could use any one of them you want to use. So I will use equation, let's say use equation 1. We could rearrange equation 1. So you could say you could make any one of them the subject. I want you to make m the subject. I will subtract both sides by n. That cancels that. So equation 3 will be now m is equal to 54 minus n. And so we just simply plug in the value of m into any one of these equations to find the value of to find the value of the other one. So I'm going to take this equation, I'm going to take equation 3, and I'm going to plug it into this equation. So anywhere we see m, we're going to put that in it. So we're going to write, so we have 54 minus n minus 3n is equal to 8. How we're going to group the like terms. So group the like terms, we have, let's say we have right back 54, and these will give us negative 4n is equal to 8. We could actually now make n the subject. So we have to subtract both sides by 54. And when we do that, this cancels that. I have negative 4n is equal to, let's say, negative 46. Right, negative 46. And if we should divide both sides by that, 4, we'll be ending up with n is equal to, let's say, this cancel that cancel that. If we should actually factor this, we could say 2 times 2, and we could say 2 times 23. That 2 cancel that 2, so it leaves us with just 23 over 2. And this was the same thing that we got when we were doing the elimination. This was the same thing that we got when we were doing the elimination. So let us continue. So we're going to plug this now, this value into any one of these equations to find the value of m. So I'm going to use equation 1 just to see. It doesn't matter which equation I want to use. So I want to use equation 1. So I'm going to plug it into equation 1. So what I'm going to do now is to say m, anywhere we see n, we're going to put 23 over 2 plus 23 over 2 is equal to 54. Want to make m the subject by subtracting both sides by negative 23 over 2. So subtracting both sides by negative 23 over 2, negative 23 over 2. So now we do the same thing for this. So that cancels that. So leaving us with m is equal to 54 minus 23. And we could do the same thing, create a fraction and multiply this fraction by 2, multiply this fraction by 2. And so going up, we have m is equal to 108 divided by 2 minus 23 divided by 2. And if we should actually do the maths, the fraction of m is equal to what we got the last time. We got 85 over 2. And so if you should convert these in actually money sense, you get 42, and that, and we'll bring back n. N is was 23 over 2, which is the same thing as 11.5. And if you should use these values to plug it into the equation, you get the same thing. So there you go. Solving real life in using simultaneous equation, both methods. All right, so that's it. Hope this video will be of good use for you, and remember to like, share, and subscribe if you like this video.